TRAPPIST-1f. The exoplanet likely rocky, orbiting within the habitable zone around the ectocode dwarf star TRAPPIST-1, located 40.7 light years away from Earth in constellation of Aquarius. The exoplanet was found by using the Tresor method, in which the dimming effect that a planet causes as if crosses in front of its star is measured. It was one of four new exoplanets to be discovered orbiting the star in 2017 using the observations from the Spitzer Space Telescope. The planet is likely tidally locked and has been depicted as an eyeball planet in artistic expressions by NASA. It is Earth-sized exoplanet, meaning it has a radius close to that of Earth and has an absolute temperature of 218 K or minus 67 Fahrenheit. It has a radius of 1.045 Earth-way and a mass of 1.039 Earth mass. It was initially estimated to have a much lower mass due to a low density of 3.3 grams per centimeter and a gravity around 6.1 meters per second. 62% of Earth's value. This suggests a large amount of volatiles, with a 2017 study suggesting that the ocean may be compressed as much as 20% of the planet's mass, increasing the temperature at the bottom of such an ocean to above 1400 K, 2060 Fahrenheit. However, refined density estimates show that TRAPPIST-1f, like other planets in the system, is only slightly less dense than Earth, consists with a rocky composition. Atmosphere. According to simulations of magma ocean atmosphere interaction, TRAPPIST-1f is likely to retain friction of primordial steam atmosphere during the initial stages of evolution, and therefore today is likely to possess a thick ocean coated by atmosphere rich in abundant oxygen. Helium emissions from TRAPPIST-1f has not been detected as of 2022. Its host star is an M-class star. It's 0.08 of our star's mass and 0.11 of our radius. It's 2,550 K and 7 to 8 billion years old. This planet orbits every 9.206 days. Um, it's really close. Habitability. The exoplanet was announced to be either orbiting within or slightly outside the habitable zone of its parent star, the region where, with the correct composition and atmospheric properties, the glow water may exist on the surface of the planet. On 31st of August 2017, astronomers at the Hubble Space Telescope reported the first evidence of possible water content on the TRAPPIST-1 exoplanets. TRAPPIST-1f has a radius about the same as Earth, about 1.045 Earth radius, but was initially thought to have only about two-thirds of Earth's mass at about 0.68 Earth mass, so it was considered somewhat likely to be a fully rocky planet and extremely unlikely to be an Earth-like one. That is rocky with a large iron core, but without a thick hydrogen-helium atmosphere enveloping the planet. Simulation 2017 suggests the planet is approximately 20% water by composition, much higher than that of Earth. With such a massive water, and the pressure and temperature will be high enough to keep the water in a gaseous state, and any liquid water will only exist as clouds near the top of one atmosphere. Based on this study, one F is therefore likely to be no more habitable than any other ice giant with water clouds in its atmosphere. However, refined estimates show that TRAPPIST-1f has about the same mass as Earth and the other planets in the system. It is only slightly less dense than Earth, consistent with a rocky composition. Its host star is a red octagonal dwarf, with only about 8% of the mass of the Sun. As a result, stars like 1F have the ability to live up to 4 to 5 trillion years, 4 to 500 times our Sun's age. Because of this ability to live for a long period of time, it is likely that 1F and all the planets will be one of the last remaining stars in the universe known than now. The planet is very likely tidally locked, with one hemisphere permanently facing the star while the opposite side shrouded in eternal darkness. However, between these two intense areas there would be a sliver of moderate temperature called the terminator zone, where the temperature may be suitable around 32 Fahrenheit to for liquid water to exist digitally. A much larger portion of the planet may be, however, if it's supposed a thick enough atmosphere. I'm gonna be honest. Here's my thinking. If it's tightly locked and it's on the it's almost outside the habitable zone. I mean, why the Terminator zone? It would be probably within the eyeball that would have the favorabilities. I mean, D and E, you could argue that yes, but this, no. It's probably closer to the Terminator zone that's habitable. Then it's probably too cold in this area, and it's definitely too cold on the other side. Yeah, but such a planet would probably already be probably an ice ball. I mean, what do you think? I mean, you're talking about something that is much colder than Earth, but it gets constant energy on within the eyeball, which you're talking about planets radically different than Earth. I mean, fundamentally in every way. I mean, it's something to think about. If it has an atmosphere and it ain't blowing, but it probably does because it's further away from its star compared to B, C, and D, but not by much. I mean,